Hey guys, so this is Mr. Yo again. Today we're going to talk about the moles. This is one of the, I would say, the easiest, unless you make some mistakes with it. But it is the easiest, and also it's heavily based on math stuff and calculation. So bear with me. If you have any questions, feel free to leave comment below, or you can ask me during class. So let's get into it. So the mole. Using dimensional analysis to solve chemical quantities. Alright, so a mole is basically a unit, such as when we measure a length, we would use meter, centimeter, or millimeter. If we measure weight or mass, we would use kilogram, grams, or so on, etc. So we use certain kind of units in order to represent or show how that specific number represent a specific term or a specific object. Alright, so let's get into it. So why do we use moles? Okay, so a mole can count things such as about 5 million hydrogen atoms can fit on the head of a pin. Okay, we need a convenient unit to count by, and that unit is called the mole. Alright, that's basically what I said before. So, in a mole, usually it represents 6.022 times 10 to the 23rd things. Alright, this is a number, this is a very important number if we want to actually understand what moles are. So it's kind of like a conversion factor. So when they say the thing, that's something that I'm going to explain as we go on. So, let's get into it. So a mole is an SI base. If you guys know what an SI means, it's basically an international unit. Alright, so an SI base unit used to measure the amount of a substance. And the abbreviation for that is MOL. Okay? When they say amount of substance, okay? Well, let's get back to it. So a mole, what it's basically representing as is a set of number. I'm going to use a number sign. Number of things. Okay? And what are these things that they're talking about? Okay? These things are basically representing the atom and or molecules. Okay, this is the only unit that we're using for today, and this thing, or basically they're heavily talking about the smallest thing that we see on Earth. Okay, and those are atoms and molecules. So that's why we use the unit called mole. So a mole. So the periodic table tells us the molar mass, okay, of each of the elements, meaning how many grams are in 1 mole. Alright? For instance, aluminum is 226.98. Okay, so when we look at a periodic table, we need to focus something. So if we go back here in the periodic table, we see all these numbers below the names or the elements. Alright, so we see, for example, iron has 55.845, and the units are usually grams for these. So these are grams, and it's saying that within a mole, or in this case, in 1 element, there is a mass of 58.9, or going back to iron, 55.845 grams per mole. So in 1 mole. Alright, that's basically what it's saying on here. So if we go on to the example here, it says aluminum, and we are going to look at aluminum. It says, alright, it says 26.981538, which is about 26.98. Same thing. Alright, and when we're doing this, I don't know if you guys remember sig figs. I know it's a little bit annoying, but let's place it as 4 sig figs. Alright, or a significant figure, as it always says. So in this case, it would be 1, 2, 3, 4. 4. All right, 4 sig figs right here. Okay. Next, to determine the formula mass, count the number of atoms and multiply by the molar mass, okay, of each element. All right. If you guys are still confused, we're going to actually solve out a problem. So we have potassium, manganese, and 4 oxygen in this compound. All right. So basically, what it's doing is what we're trying to find is how much mass, a molar mass, or a mass there are in this formula. So how do we do that? What we do is we separate them into elements. So we have K, we have Mn, or manganese, not magnesium. Sorry about that if I got it wrong. And oxygen. Okay, so we're adding those together. But remember, we have to look at the subscripts in order to see how many there are in each. But for potassium, there's only 1 because there's nothing on there. Manganese, there's only 1. And for oxygen, there's 4. So what we're going to do is I'm going to put a 4 here. Okay, that looks like an 0, but bear with me, it is oxygen. So there's 4 oxygens in here. So potassium, if we look at it on our periodic table, potassium is right here. Potassium is 39.0983, but we're going to round it to the 4th sig fig. So since it's 9 and this is higher than a 5, we're going to put 39.10 as its sig fig. Manganese. So manganese is 54.94. Okay, 54.94. All right. And we're going to put a plus sign, and then 4 parentheses because we're trying to multiply it by the individual oxygen's mass. So oxygen has 15.99994. So this is a 9, so it will round up to 16. But remember, keep it in 4 sig figs. All right. So I'm going to use a calculator to solve this out. So we have 39.10 plus 54.94 plus 4 times 16. All right, and we get 158.04. Okay, and the unit for this would be grams because each of them represent as grams. So grams per mole. Okay, and this mole represents this formula right here. All right, so now you found out how much mass it contains within this formula. So that's basically what you're doing for this whole thing. All right, it's not that difficult. If you guys are still confused, I mean, feel free to ask me any questions. But we're gonna just keep on going. So it says determine the formula mass for each of the following compounds. Okay, so let's do this quickly. So potassium, K, and we're doing Cl. All right. So potassium has 39.10. That's basically a number from the previous one. Chlorine, let's see. Chlorine is right here. 35.45. All right. 35.45. You're going to add that. So that will give you 39.1 plus 35.45 will give you 74.55. 74.55 grams per mole. I'm going to put as G, as grams per mole. Okay? So this is what you get for this section. Oops. That's how it is. Alright? So for calcium nitrate with a 2, so you're multiplying it. So we're going to put Ca, calcium. In this case, we're going to put a bracket. Alright? 2. Because this 2 represents an overall of this whole thing within it. So we have a nitrogen plus 3 oxygen and close parentheses because there's 3 oxygen right here. Alright, so calcium. How many are there in calcium? There is 40.08. Okay? And 2 with nitrogen has 14. has 14.01 plus 3 parentheses 16.00. Okay, so if I calculate that, I would get A plus 2 times 14.01 plus 3 times 16. Okay, don't forget there's 2 parentheses within here when you plug it in. So that's 164.1 gram per mole. Okay, that's basically it. That's basically what you're doing. Alright, so we have 2 more to go. So Na has 2, there's 2 Nas, sodiums, plus S plus 4 times O. Okay, so N, how many are there, or what's the mass of Na, or sodium? That's 22.99, okay, 22.99, plus sodium, not sodium, sulfur has 32.07 plus 4 times 16.00. Alright, that would give you 142.05 grams per mole. Alright? Okay, next. There's 2 aluminum. Alright, I'm going to speed this through because it's basically calculation. S plus 4 times O and parentheses. Okay, so that means there's going to be 2 aluminum. Aluminum is 26.98. 3. Sulfur is 32.07 plus 4 times 16. Okay, so I'm going to speed this again. So 26.98, 32.07 plus 4 times 16. Alright, that gives you 342.17 grams per mole. Alright guys, so this is basically what you guys are doing. If you have any questions, feel free to ask. The next page is basically practice problems for you guys to solve. If you have questions, ask me. If not, then I guess that's a good sign. But if you really have questions, please do ask me. Alright, I'm here for you guys. I'm here for you guys so that I can help you guys out. Okay? Alright, let's go to the next page and solve some problems. Alright guys, so now it's the molar mass worksheet. So in this, what you're basically doing is calculating the molar mass of the following chemicals. So you're just finding the mass of what you have done, or finding the mass of each of these compounds. Alright, it's not that hard. So you don't actually use the units, or actually the conversion factor, like this number, 6.022 times 10 to the 23rd. You don't actually use it in this scenarios. You're just finding what the molar mass is. So as in, what is the mass of the overall? Alright, so let's do this. Alright, so we have Cl2, so that we have 2 chlorines. Okay, if we have 2 chlorines, that means 2 times how many mass is chlorine? There's 35.45 grams. Alright, so I'm going to multiply that by 2. So 2 times 35.45 gives you 70.9 grams per mole. Okay, that's the first one. Second, K plus O plus H. Okay, so K, potassium, is 39.10. Yes, 10. Plus 16.00 plus hydrogen has 1.01. Alright, so we're going to add that together, which will give you 56.11 grams per mole. Okay, it's very simple. As you keep on solving these problems, you will probably speed everything up. Alright, just please don't make any mistakes, such as looking at the periodic table wrong, or just writing stuff down wrong. Alright, so let's see, Be is beryllium. Beryllium is 9.0 9.01 plus 2 times chlorine. Chlorine is 35.45. Okay, so that's 9.01 plus 2 times 35.45. Okay, that would give you 79.91 grams per mole. Alright, simple as that. Alright, there are 14 problems, so I'm going to speed things up. So I might not talk in this while I'm doing this. So my apologies. Just follow through with me. Okay, and also when you guys are trying to check some answers, just pause the video so you don't miss anything. Alright, if you do miss something, well, good luck. Alright, so let's see. Boron has 81, has 19. Okay, and if you think that there's some answers that are wrong, just tell me during class, or just put a comment below, because everyone makes mistakes. I'm talking too much while I'm solving problems. Okay, let's see. CO. Okay. U, where's U? It's been a while since I seen that element. Where is U? Oh, uranium. I forgot the unit. Alright. Always do not forget about the units, because if you guys get the units wrong or do not write any units, I'll mark it off as if it was wrong, or a half point for it. Alright, and also as you go on, you will most likely memorize some of the elements' mass, because you've been using it so long that everything just comes into your head. So alright, for this one, it's 98 grams per mole. Usually I shouldn't write this down, I should have made a 2 sig fig. You would put 0.00 in order to make it 4 sig fig. Alright, so we have 4 more problems left. So we have 2 overall, n plus 4 times h, plus s plus 4 times 12. Okay. n is 14.01 plus 4 times 1.01 plus s is 32.07. That'll give you Alright, that will give you 132.17 grams per mole. Okay. Alright, so let's go on. Okay, we have C plus 3 times H plus C plus O plus O plus H. Also guys, when I'm actually solving these out, I never actually write it into this setup. I'll just write down the numbers on its own, but for you guys, I'm just in case, if you guys forget any elements while you guys are adding things up, I'm going to write things down step by step. So, let's see. Give you 60.06 grams per mole. Okay. 60.06 grams per mole. So that's PB plus 2 times N plus 3O. Okay. Sorry if that looks like a 30 right there, but it's an O. 3 times O. So PB, where's PB? PB is located. I don't know why I can't see PB. Oh, PB. What? It's 207.2. Okay. Plus 2 times N. N is 14.01. Plus 3 times 16.07. Okay. Give you 331.22 grams per mole. Alright, lastly, 2 times GA plus 3 overall times S plus 3O gives you, so G, where's G? I believe it's gallium, if I'm wrong. GA? I really can't find GA. Where's GA? Oh my goodness, where's GA? Alright, something is wrong with me. Where is GA? Oh, it's here. Oh my goodness. So gallium is 69.72. Okay, 69.72 plus 3 times S. S is 32.07 plus 3 times 16.00. That will give you That'll give you 379.65 grams per mole. Alright, so we solved every single one of these problems now. So this is all you're doing basically for mole mass worksheet. If you have any questions, feel free to ask me any questions during class or on the comment below. So please ask me questions. Asking questions is not a bad thing, it's part of learning. So I'll talk to you guys later, and I'll move on to the next lesson as we go on. See you guys later. Bye.